So for problem 24, we are given the parametric equations x is sine of t, y is equal to 2 sine of t plus 1. And the first thing that we want to do here is eliminate t to just have an equation in terms of x and y. So x is sine of t, y is equal to 2 times sine of t plus 1. So if x is equal to sine of t, it therefore means that y is going to be equal to 2 times sine of t, which is x. So 2 times x plus 1. So this here is our equation. But we are not done because this equation y is equal to 2x plus 1, that's a line. It goes infinitely. However, the parameter t is limited. It goes from 0 to pi over 2. So this means that this line here also has to be limited. It's going to be a line segment. So we need to express the restrictions of the input t in terms of the restrictions of the input x here, because now in this equation, x is an input. So we're going to plug in the first boundary of t, the lower one, t is equal to 0. So if t is equal to 0, x is going to be sine of t, so sine of 0, which is equal to 0. So that's a lower boundary. And if t is equal to pi over 2, if t is equal to pi over 2, then x is going to be sine of pi over 2, which is the same thing as 1. So we can see that the input here, x, is going to be bounded between 1 and 0 because x is sine of t, and t itself is bounded. So once we have this, we have our equation, our parametric equation, right? And what is missing here, so let me remove this. So that's our equation. And for item B, we have to describe the curve and indicate the positive orientation. So because this is a line segment, we do have to get the coordinates of where it begins and where it ends. So we're going to say the curve is a line segment described by y is equal to 2x plus 1, which begins at, so this curve here begins at x is equal to 0, and so if we plug in 0 in the curve, so y is equal to 2 times 0 plus 1, which is equal to 1, right? So it begins at the point 0 for x and 1 for y, and ends at, so the upper boundary for x is 1, and if we plug in 1 there, we're going to have y is 2 times 1 plus 1, which is 3. So it ends at the point 1, 3. And that is it for problem 24. We were able to see that the parametric equations, they describe a line segment of the form y is equal to 2x plus 1, where x is bounded between 0 and 1.